Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3 RTV digital channel 1 in HD. We're also broadcasting on Discord, my Discord channel in HD. As I said in previous weeks, Discord probably provides the better video aspect, so that if you're listening to the transmission here on 80 meters, the video side of it can be followed on my Discord channel in almost near real time, less than a second delay with what you're hearing on 80 meters, as opposed to YouTube, which is anything up to 20-second delay. So as I always say, to go to the Discord website and register. It's all free. Just a few questions have to be asked, and then if you go to my YouTube QRZ page for my home call sign VK3CSJ, Charlie Sierra Juliet, or the call sign here VK3EKH. I provide a link to the Astronomical chat room, which is also associated with the video channel stream. So look at Discord. Otherwise, YouTube, I am streaming there, providing the modem doesn't fall over from RF ingress. Anyway, the YouTube stream is running for what it's worth as well. So yes, good evening everybody. This 21st of February, and temperature is currently 23.8 degrees here in Narre Warren South, and we're zooming up to 36-37 degrees tomorrow. So tomorrow is going to be one of those scorching days. Anyway, we're here tonight, and we've got a few little articles. We'll probably finish a bit earlier tonight. I think I say that every Friday, and I always go over time, but nevertheless. We also have an email address if you wish to send signal reports and general things, correspondence, vk3ekh@gmail.com, vk3ekh@gmail.com, and I'll check that out throughout the evening. In fact, I don't think I've got that open right in front of me, so I'll just open that right now. Okay. Sorry for that noise in the background. I think that's one of my cats playing around with the paper bag. Okay, let me just bring up my email for VK3EKH. There we go. All right, so I'm there, and I'll just check that every now and then. All right, now, as I usually do, for those stations that are tuning in for the first time, so I'm going to read the usual thing out here. Should make a recording of this. The Astronomical Society of Victoria was founded in 1922 and comprises well over 1,800 members throughout Victoria, the other states of Australia, and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night, although I think that has now changed. Meetings starts at 8 p.m. at the Mullier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is also located adjacent to the Shrine of Remembrance. Parking is available at Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV's magazine Crux containing news articles, news observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector, the 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try before they buy. Regular Society Club Night meetings are held at the Melbourne Observatory in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre radio telescope which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research in astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.au. Notifications of events and of events are given in the Crux Extra Bulletins, which are sent out via email to members. Please note that the ASV will conform to all government health directives, thus ASV events may be required to be cancelled, moved or postponed. If you wish to send a letter to the email the ASV, the mailing address is the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001, if you wish to contact the ASV via mail. Otherwise, like I say, visit the ASV website at www.asv.org.au and all will be revealed there. Membership is easy peasy. The page is available with the where you can open up the page to look for all that information for becoming a member. It's all via PayPal these days, and it's, like I say, it's all fairly easy to do. All right. Now, like I say, there's a few things tonight. A little bit of a theme on this asteroid that it's been in the news lately. And I've got these two little black cats mucking around here. So if you hear funny noises or if I go off air, it's because they've pulled the cord out of the wall. Okay. Now, firstly, also next Saturday. The ASV has its Messier Star Party, if I can find my mouse. Messier Star Party, which is open to public, and if you go to the homepage for the ASV at www.asv.org.au, there's a revolving banner at the top of the page, and at some point you'll see it open up to the Messier Star Party. There it is there. I've got it on the now. Just stop for for a sec. Oh my God. Right. As it says here, a unique stargazing opportunity, Messier Star Party, general public tickets from at March the 1st. Leon Mao Dark Sky sighted north of Heathcote. Galaxies, nebula, clusters, explore the night sky. Hopefully the weather will be good. Book now. So anyway, all that information is available from the homepage, and as far as I know, there's obviously, I think there's still room available up there, but I would to check out contacting the ASV to see what's involved in going up there if you haven't been up there for if this is the first time. But you'll get an opportunity to look through telescopes. There'll be no doubt there'll be a whole bunch of telescopes up on the observation field. I suspect the 40-inch telescope will be out for a viewing through, and the radio telescope facility should also be available to go into and have a look at and speak to the radio astronomers there as well, and they'll ask them any questions, any technical questions they'll have an answer for. And they hope, I know that they hope to have their radio telescope, the big dish, working and being displayed as well, which will be good. All right, so that's next Saturday, March the 1st. Let me just check that calendar. Yep. And hang on a sec. Catch up to something here, and so that's next weekend. Hopefully the weather will be nice. All right, let's move along. Vastrok, yes. August this year, the 9th and the 10th of August is Vastrok, the Victoria Astronomical Conference. So they're obviously out to get people to do presentations. I haven't seen any program at this stage, but August this year will be Vastrok. ASV will be hosting Vastrok, which will no doubt be a very interesting Saturday and Sunday, full of interesting presentations and demonstrations as well. I can see my black cats in the background behind me there on the TV. Okay, so that should be interesting. And now we'll go to the first article tonight, which I've got something here, courtesy of Science Alert. Radiation from an exploding star may have altered evolution on Earth. This was published 21st of February. And there's a graphic image here, which I'll see if I've got here. Did I bring it across? Yes, I did. And I'll bring that up as well. It's just me, little insert there on the picture. Okay, now I haven't had a chance to really check this article out. It just looked interesting. If a star explodes in space and no one is around to see it, does it wreak a change on terrestrial evolution, is the question. Well, yes, maybe. If you are a microbe quietly minding your own business in a lake somewhere in the highlands of eastern Africa perhaps, a new study has found that an explosion in virus diversity 2.5 million years ago in a lake called Lake Tanganyika, something like that, occurred at the same time, and radiation from an ancient supernova bathed Earth in cosmic rays, it seems. This could imply a link between the diversification and cosmic radiation, according to a team led by astrophysicist Catalin Norigi of the University of California in Santa Cruz. She says it's really cool to find ways in which these super distant things could impact our lives on the planet's habitability. Radiation is thought to be one of the contributing drivers of evolution here on Earth, a chaotic influence that pushes cells to mutate for good or for ill, or for neutral. Evolution would happen with or without radiation, but it can play a role in nudging changes along. The solar system sits in a bubble in space known as the local bubble, a region relatively devoid of other stars. Astronomers believe that this bubble was carved out by a series of supernova explosions millions of years ago. Since nearby supernovas can boost the radiation levels experienced by Earth by several orders of magnitude, it's reasonable to explore the possibility that this radiation affected life on the surface. The work of Norigi and her colleagues involved core samples of deep sea sediments, preserving a record of disposition over millions of years. In particular, they were looking at a radioactive isotope of iron called iron-60, which is forged during supernova explosions and rains down on Earth in greater quantities when we travel through remnant clouds of supernova debris. Back in 2016, a team of physicists published a paper in which they described the identification of two spikes in iron-60 in seafloor sediments. Because iron-60 has a known half-life, these spikes could be dated with a high level of accuracy, one to around 6.5 to 8.7 million years ago, the other to around 1.5 to 3.2 million years ago. Norigi's team wanted to trace these spikes to specific events, so they set about rewinding the motion of objects in local space. Their results show that the earlier spike in iron-60 occurred when Earth entered the local bubble, passing through the boundary region rich in the isotope from previous supernova explosions. The later spike, they found, was likely the result of a supernova explosion nearby between 2 million and 3 million years ago, either from the Scorpius-Centaurus group or a group of young stars from 460 light years away, or the Tucani hologram group 230 light years away. A supernova remnant and associated runaway stars in Scorpius-Centaurus, one of the later being a pulsar, the collapsed core of a dead star after a supernova, suggests that this region is the most likely of the two to be the culprit. Indeed, a 2019 study already linked the iron-60 spike to this very supernova event. The team performed simulations to find out how this explosion would have affected Earth, aside from the iron-60 spike, that is. They found that our planet would have been bombarded with powerful cosmic radiation for around 100,000 years in the wake of the supernova. If the explosion took place in Scorpius-Centaurus, the dose could have been an additional 30 milligrays per year during the first 10,000 years. For Tucani hologram, it's a difficult word to pronounce that one, the dose would have been 100 milligrays. Either way, there may have been effects. A 2016 paper describing research conducted in India found that the radiation threshold for breaking DNA may be around 5 milligrays per year. While there's no direct line drawn between the two events, a paper last year found a startling increase in diversity of fish viruses in the lake, in this particular lake, Tanganyika, between 2 and 3 million years ago. We can't say that they are connected, but they have a similar time frame. We thought it was interesting that there was an increased diversification in the viruses, she says. At the very least, the research suggests that there may be a link between wild events in the cosmos and the trajectory of evolution here on Earth. We may say that we exist in a bubble, in a vacuum, but truthfully, all things can affect other things. Or as Carl Sagan famously once said, we are all stardust. And maybe we should think about that more than we do. The team's research has been published in the Astrophysical Journal Letters. That article is from Science Alert, and it's titled "Radiation from an Exploding Star May Have Altered Evolution on Earth." You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast at 10:21. Alrighty then. Next here I have, courtesy of astronomy.com, australia.com, astronomy.com. Okay, this is nice and short, and there's a graphic for this as well. Let me just bring that up. Where's that graphic? There it is. And I'll bring my little insert back in again. Okay, now this is titled, "After our sun becomes a white dwarf and cools completely, what will be left?" is the question. Our white dwarf sun will cool for billions upon billions of years, slowly fading away as a dark, solid carbon-oxygen ball, which is that illustration there on the screen, I suspect. What it says here is that in 2019, astronomers announced that they'd found direct evidence of white dwarfs solidifying into oxygen-carbon crystals. As depicted in this artist's illustration, after the white dwarf becomes completely frozen, it cools off and fades as it stops generating light. And looks something like what's on the screen right now. Okay. So, our sun will become a white dwarf in about 7 billion years. At that point, it will no longer produce energy through nuclear fusion, having exhausted its fuel, hydrogen and helium, just like the embers of an abandoned campfire can only cool down with time. The white dwarf sun will gradually become dimmer and cooler as it radiates its heat away into space. The interior of this type of star is incredibly dense. To put this in perspective, a volume of white dwarf material equal to a teaspoon would weigh several tons. In such a condensed state, charged particles, oxygen and carbon nuclei, interact strongly due to the powerful electrostatic forces at play. Initially, these charged particles don't feel this force too much because they're moving quickly in all directions thanks to the star's very high temperature. But as the white dwarf sun cools, the particles in its interior slow down. Eventually, they become so slow that they can't overcome the electrostatic interactions squeezing them from all sides, and they become trapped. The interior of the white dwarf sun will literally become a solid carbon-oxygen crystal. This freezing process, known as crystallization, is predicted to start roughly 3 billion years after our sun becomes a white dwarf, or about 10 billion years from now. Since diamonds are a solid form of carbon, it's often said that white dwarfs turn into diamonds. However, this isn't entirely accurate. The matter inside a white dwarf is very different from a diamond. The interior of a white dwarf is not only much denser than anything found on Earth, but also much hotter, even by the time the star freezes. Once completely frozen, our white dwarf sun will continue cooling for billions upon billions of years, slowly fading away as a dark, solid carbon-oxygen ball. That's our future. You're tuned to ASV Radio on behalf of the Astronomical Society of Victoria, the regular Friday night broadcast. Coming to you from the studios of VK3CSJ in Narre South. Okay. And now there's a graphic for this one too. Let me just switch to this graphic. Picture, in other words. NASA has some good news. About the asteroid that could hit Earth. And this was published today. Oh, excuse me. That's it. My coffee went down the wrong way. That's it. I can't talk. I'll see you all next week. Testing 1, 2, 3. The chance that asteroid capable of wiping out a city will hit Earth in 8 years has been cut in half to around 1.5%, according to new calculations from NASA. The drop in odds had been widely anticipated by the global astronomical community, which now broadly expects the probability the asteroid will hit Earth on December the 22 in 2032 to fall down to zero. For more than 24 hours, the asteroid did have the highest probability of hitting Earth at 3.1%. Of such a big space rock in modern forecasting. Updating calculations posted by NASA late Wednesday said that the odds of a direct hit had fallen to 1.5%. The European Space Agency separate calculations plunged to 1.38%. Richard Mosseli, head of ESA's Planetary Defence Office, told AFP this had been expected as the uncertainty region where the asteroid could strike starts off to slip off Earth. The percentage change will likely still wiggle slightly up and down a bit, but it's now expected to soon fall below 1%, he added. It's not clear whether that will happen before the James Webb Space Telescope turns its powerful gaze to the asteroid next month. There is still a 0.8% chance that the asteroid will hit the moon, according to NASA. The asteroid, which is known as 2024 YR4, was first detected in December. It is estimated to be around 40 to 90 metres wide, which would not cause a global catastrophe, but would still be capable of causing significant destruction to a city if it was to hit. The last time an asteroid of greater than 30 metres in size posed such a significant risk was Apophis in 2004, when it briefly had a 2.7% chance of striking Earth in 2029, a possibility later ruled out by additional observations. Now, I'm going to go across to an interview that I saw just a couple of days ago. With Chris Hadfield. So this is a 10-minute video, which I'll queue up. This is courtesy of leading what's called LBC, Leading Britain's Conversation. And the female host is Rachel Johnson. And I think this is pretty much an online forum. But it's called Leading Britain's Conversation. Yep, Leading Britain's Conversation. And Rachel Johnson's talking to Chris Hadfield, who's the Canadian astronaut that we all know one way or another. A little bit more on him in just a moment. But let me see if I can just get this queued up. And hopefully it will come across without too many problems. You're tuned to ASV Radio, VK3EKH. I'm still doing that at the moment. Damn. Let me just
Chris Hadfield, though, let's go to the asteroid that could hit the Earth. Chris Hadfield is a colonel astronaut who's now retired. He's also an author, and he's coming to the UK for a tour, Chris. And I think the tour is called A Journey into the Cosmos.
Yeah, thanks. It's good to be speaking with you. I'll be there in June, a bunch of cities across the UK and over to Dublin for a couple talks as well. Looking forward to it very much. There's so much stuff going on Earth, orbiting the Earth, and to the moon and beyond. Millions of things to talk about. But one of the things we should talk about today, I think, is this asteroid.
Does it have a name yet?
Well, it was discovered on Christmas Day, and it's going to be back in 2028, just before Christmas. And if it does smuck into the Earth, it's going to be in 2032, just before Christmas. So I'm calling it the Christmas asteroid.
It's incredible that scientists, astronomers can determine to such precise date, even probably time, when it's going to hit. So first of all, Chris, how do they know?
With a bunch of telescopes. Most of the telescopes are on Earth. In fact, most asteroids are discovered by amateurs, people with their own telescopes who just love looking into the darkness and trying to find a star that's where star shouldn't be, or one that's moving against the star field. But this one is very faint. It has never been seen before this Christmas, just right on Christmas Day of 2024. But now all kinds of telescopes are trained on it because it's going to come quite close to Earth in 2028, and then potentially, very small probability, like 1 in 45 chance of hitting the Earth just before Christmas at 2:30 in the afternoon on I think it's the 22nd of December in 2032. So because it has a probability of hitting us and doing damage, we're really having a good look.
So the probability has jumped from 1.2% in January to 2.3% in February. Tell us about the consistency of the asteroid and how that will affect the impact it has on Earth if and when it hits.
Sure, it's hard to figure out what those numbers even feel like, right? But it's like, right now it's about 1 in 45 chance of hitting us that day. So, 44 chances out of 45 it wouldn't hit us, but 1 in 45, that's definitely not zero. The reason we don't know for sure, it's sort of like if you play billiards or shuffleboard. The moment you release the shuffleboard weight or you hit the pool ball, you're pretty sure where it's going to go, but it's not 100% sure, and there's some variability, and you've got to watch it for a while to figure out where it's going to hit. And we have a lot of good telescopes looking at it, but what's really going to answer it is the big, powerful James Webb telescope is scheduled to have a good look for it next month and in early April. And that will really help us refine exactly where it is going to be on that day in 2032, whether it'll intersect the orbit of the world or whether it'll give us a near miss.
So according to this piece, it's less than 100 meters wide, which is maximum 300 feet wide. And if it breaks, what's worse for us here on Earth if we manage to strike unlucky and it does hit us? What's worse, if it breaks into smaller pieces before it enters Earth's atmosphere, or it hits us in one piece?
Yeah, that's a hard thing to say because it kind of depends where it's hitting. And we don't really even know how it's made. It may be one solid rock from some old bit of a broken up planet, like one big boulder that's 60 meters across, big lump of rock. Or it might just be an agglomeration of millions and millions of stones and lumps and boulders. We think, because of the way it reflects light, that it's probably a stony asteroid, a bunch of bits of other things that have slowly coalesced together. So it probably won't break up. It'll sort of burn up coming through the atmosphere. But if you go to Phoenix, Arizona, in northern Arizona, right by the Grand Canyon, there's a huge hole in the ground, more than 1,000 meters across. And that was from an asteroid about the same size as this one. It hit the Earth 50,000 years ago. And if you go up into Siberia, up in the Tunguska area, we got hit by a meteorite like this about 120 years ago, and it flattened the forest for like, I don't know, 1,000 kilometers, because it was an air burst. And
So
whether it
explain,
broke it,
sorry to interrupt, but explain how something that's less than 100 meters wide can impact 1,000 square meters, 1,000 square miles of the Earth's surface.
well, because it has 7.7 megatons worth of TNT, it's about 500 times more powerful than the biggest bomb we exploded during World War II. 500 times more powerful. So think of the destruction we wrought on each other in Hiroshima and Nagasaki. This is 500 times more powerful than that, just because of the energy of it coming through the atmosphere, causing shock waves, and because of the heating, exploding. So it's like a grenade. A grenade is no bigger than your fist, but it can do damage over a wide area. This is a grenade that's 60 meters across.
Wow. But with none of the radiation associated with Hiroshima and Nagasaki, though.
Correct. It's just a rock.
It's a rock.
Or a collection of stones. But a collection of stones and rock going 17 kilometers a second.
Wow.
Just think how fast that is. The space station's only going 8 kilometers a second. I lived up there for half a year. It's going twice as fast as the space station, like a bullet zeroing in on Earth from deep space. The odds are it's going to miss us. And by springtime, we'll know even better. The best part is, and I'm sure you want to ask me about it, Catherine, is we have plans if we know for sure, or we think that
tell us what the plans are.
Right. Well, back in 2001, 2002, or 2021, 2022, we were thinking about this, NASA and other agencies. And so we actually launched a probe to go hit an asteroid and see if we could deflect one or not. Sort of like the precept for the movie Armageddon, although that movie was terrible. But could we do it or not? And we actually found in 2021, we launched a probe. And in 2022, we were so good at it that we crashed into this asteroid, and we could measure it afterwards. What did it do to it? And it deflected it. And it's almost like a pool ball.
How do you do that? Yeah.
Oh, you just crash into it. But if you hit it early enough, you just have to change its trajectory a tiny bit. Like if a pool ball was rolling across and you just blew on the side of it, you could make it miss at the other end. So just if you get it early enough, then a tiny angular change will cause it to miss the Earth. So we still have until 2032, and it's going to come back close to Earth in 2028, and we should know pretty well this spring. So if we had a big fear because of our best math that it was actually a threat to humanity, then we would organize ourselves and do something about it. But who's going to do that? Who's going to pay for it? There'll be all sorts of politics involved. But at least we know that we're capable of saving the Earth. And that's one of the pretty interesting benefits of the human space program.
And we have the capacity to send up a probe or whatever it is, and so that whatever happens, an asteroid is not going to strike the Earth in 2032.
Well, there'll be lots of little asteroids strike. The Earth gets hit by 40 tons of asteroids every day. 40 tons of rock hits the world every day, but they're little, and they burn up in the atmosphere. And when you look at the motes in a sunbeam of little bits of things, those are vaporized bits of asteroids mostly that have hit the Earth. So that's normal. It's rare to have a big one. And that's why we have all of these Earth protection sensors and telescopes, and we're trying to protect ourselves. And we now, for the first time in the history of humanity and the planet, the dinosaurs didn't have one of these. They just looked up from their vegetables and died. We have the ability to protect ourselves. We have to organize. We have to decide it's the right thing to do. Someone has to spend the money. But at least we have the proven ability to do something about it. And it's nice that here, 7 years in advance, we've already detected this approximately 60-meter rock. And now we're just refining our knowledge to make the right decision.
And is there a chance that there is an asteroid out there that we haven't spotted, unlike the Christmas one?
Oh, yeah. There's almost an unlimited number of them.
And no, but heading towards us, I mean.
Well, they're the same color as space. and often they don't reflect light very well, and so they're hard to see. But we found thousands and thousands of them. We have them all cataloged, but we keep looking, trying to make sure our database is as complete as possible. Nothing's perfect, of course, but this is a good example of how much more perfect we are now than we were even 10 years ago.
Thank you very much. That was an absolutely fascinating out-of-body experience talking to you. Chris Hadfield, the Colonel astronaut, also the author, who's coming to the UK for a tour later this year, which is called Chris Hadfield, A Journey into the Cosmos.
Okay. Thank you to the Leading Britain Conversation for that, and Rachel Johnson interviewing Chris Hadfield, and that was just a few days ago. And of course, as we get closer to this, this astro gets closer to us, either way, that percentage of hitting the Earth narrows, and calculations get better. And of course, the James Webb Space Telescope is turning to study it in the next month. So once that trains its magnificent eye onto the asteroid, we'll get a better view of it, and the calculations will improve. So apparently, though, if it was to strike, the damage zone is through Europe or somewhere in that region. There was actually a picture I saw of the potential area, so didn't grab it, but somehow I think we'll be right. Now, I'll just cut to this image. Chris Hadfield is actually doing a tour of the world, and he's coming to Melbourne. Where was that date? Where did I have that date? Just here somewhere. Join Colonel Chris Hadfield, acclaimed astronaut, test pilot, spacewalker, spaceship commander, and best-selling author, for a captivating journey into the majesty of our planet and the vast universe beyond. In this visually stunning event, Chris will present never-before-seen space imagery of Earth, the Moon, Mars, and more, in an awe-inspiring exploration of discovery. Pardon me. And that will be on the 1st of July at the Hammer Hall in Melbourne. Hammer, H-A-M-E-R, Hammer, or Hamer, maybe it's Hamer Hall. Hamer Hall in Melbourne at 7:30 p.m. on the 1st of July, which I think is a Tuesday. And there are some ticketing things involved, so you'll have to go to the Ticket Tech website to find out how much that is. And being on a Tuesday will be a bit awkward, I think, for the average working person. But anyway, if you're keen to see Chris Hadfield doing a very interesting presentation, I'm sure he'll be absolutely fascinating to listen to. Apparently, he's bringing his guitar along, and will be doing most likely his rendition of Space Oddity by David Bowie. If you haven't seen it, look it up on YouTube. It is actually quite good. He's floating in the space station with his guitar, and he's strumming away the song Space Oddity by David Bowie, and it is actually quite good. He does have a voice. He knows how to sing in key. He knows how to play a guitar and sing at the same time. If you haven't seen it, it is very good. So he'll probably do that. Anyway, so that's coming up. So it's only a one-nighter. So it'll be a good idea to see if you can book in to see Mr. Hadfield. I'm sure it'll be interesting. All right, you're tuned to ASV Radio, VK3EKH, broadcasting on 3541 kilohertz, and also via the Melbourne Television Repeater, VK3RTV, and also on Discord and my YouTube stream. And I do apologise for the lack of audio at the beginning of that interview on Discord. I suddenly realised that I had to click the little button on vMix to get that to work, so I got that working about halfway through it. G'day to Bruce and Dallas, that's sitting there on Discord, I can see. And on email, we have another one. We have a couple of folks. G'day John and Andrew. There's two Andrews there actually. 3BQ and 3KIS. So g'day chaps. Thank you for listening. And the signal report's quite good. All right. Next, what have I got here? Facebook. See, now I knew it. Bloody Facebook, I tell you. I try to keep a page open with this information on it, but it likes to. As soon as you like, it'll stay there for a while. But as soon as you go back to it, it'll just suddenly refresh all on its very own, and you lose the page. Oh, I tell you. Anyway, I found it. Okay, this happened just a few nights ago, apparently. And I've got a picture of this. vMix. Where's this picture? There it is. There we go. Having seen something like that, we'd be a little bit worried. SpaceX Falcon 9 rocket debris creates a dramatic fireball over Europe. Crashes in Poland. This is February 20. Oh dear, belching away here. The Falcon 9 upper stage failed to deorbit. Now, see, this is one of the greatest issues about all the crap that's orbiting Earth. You know, these people, I mean, they're wanting to deorbit the International Space Station by 2030, and apparently Musk and Trump want to do it earlier. They just want to get rid of it for some reason. God, I don't know why. But anyway, SpaceX Falcon 9 rocket debris creates a dramatic fireball over Europe, crashing into Poland. A Falcon 9 upper stage failed to deorbit as planned following its February 1st launch. And it doesn't go for very long actually. But anyway, I'll read it as much as I want to. A SpaceX rocket stage fell to Earth early Wednesday, blazing a trail of fire through the European skies, as you can see up there on the screen. Across the English region of Lincolnshire, the fireball was visible over homes, with locals posting images on social media. It was quite bright, so it does seem to have been quite a substantial object, astronomer Paul Money told the BBC. An early morning Reddit post showed the fireball over Berlin, and later on Wednesday reports from Poland detailed a large object that had fell from the sky outside Poznan, a large city in western Poland. Today, around 9:20 a.m, we received information from employees of one of the companies from Komunik near Poznan that after starting work they noticed an unspecified object resembling a reservoir on its premises. The Polish police said that according to a website that provides news for the city, that no one was affected as the results of this incident, however. The flaming debris was part of the upper stage of a SpaceX Falcon 9 rocket that launched 22 of the company's Starlink internet satellites to orbit from California on February 1st, experts say. The Falcon 9 upper stage is expendable, unlike the rocket's first stage booster, but is designed to be brought down in a controlled fashion shortly after launch. That didn't happen on this particular mission, however. The Falcon 9 second stage from the Starlink 11.4 launch failed to deorbit itself on February 2. It re-entered over northern Europe last night with entry over Irish Sea on February 19, and re-entry track extended to Poland and Ukraine. A couple of minutes later, astrophysicist and satellite tracker Jonathan McDowell of the Harvard-Smithsonian Center of Astrophysics said on early Wednesday morning, the Polish space agency, Polsa, confirmed that the finding in a statement noting an uncontrolled entry into the atmosphere of a member of the Falcon 9 launch vehicle. A part of the rocket weighing about 4 tons came from the SpaceX Starlink group, which took off from the Vandenberg Space Force Base in California. Later, a second object that closely resembled the first was discovered in the forest near the village, about 30 kilometres from the first debris landing site. So certainly objects fell to the ground, that is for sure. Could have easily gone through somebody's house. So that's about it. I won't carry on any further on that one. But thanks to Kate Green for the report on that. That's from the Space Exploration section's information news feed that is every day. There's numerous news feeds that Kate puts out. Really interesting stuff. It's a very active Facebook page. And just below that one, actually, I didn't save any images. Let me just go back to camera. Not that one, vMix. All right, just below that particular article that Kate's put up, the International Space Station should be deorbited as soon as possible, Elon Musk says. Let's go to Mars. And he says it has served its purpose. There is very little incremental utility. There is very little incremental utility, it says there. That's what that means. Elon Musk thinks that we should start moving on from the International Space Station. It's time to begin preparations for deorbiting. It has served its purpose, he says. There is very little incremental utility. Let's go to Mars, the SpaceX chief and close Trump advisor said. That the decision is up to the president, but my recommendation is as soon as possible, he says. I recommend 2 years from now. So there's a bit more to that article, but I don't know. I'm sure it would be important to keep that International Space Station up there running. All right. Next I've got here, before I go into space weather. This is one of these quick questions, answers. And there's a graphic for that too. Where is that? Okay. The question's asked, what will happen to the solar system when the Milky Way and Andromeda galaxy merge? This was published February 10th, so that's a week or so. Predictions are uncertain, but the solar system may be pushed farther from the galactic core or even ejected entirely from the new galaxy, it says here. Where do I start? Astronomers predict that our home galaxy and the nearest major galaxy to it, Andromeda, 2.5 million light years away, will collide and eventually merge between 3.9 billion to 5.6 billion years from now. They have been fairly certain about this since 2012, when researchers precisely measured the motions of many stars within the Andromeda galaxy and found that these stars are approaching the Milky Way. Presently, the two galaxies are moving toward each other at 402,300 kilometers an hour. So that in the time required for you to read this sentence, the separation between Andromeda and the Milky Way will have diminished by nearly 1,300 kilometers. Astronomers also know that these two galaxies will not merely crash together Instead, they'll undergo a series of encounters. According to a recent model, the first merger will occur about 3.9 billion years from now. The galaxies will then separate, slow down, and move back toward each other before colliding again in 5.1 billion years. The subsequent separation will be briefer because their gravity will prevent them from straying too far apart. In about 5.4 billion years, the two galaxies will finally merge into a galaxy of more than 1 trillion stars. So, what will all this galactic motion do to the solar system, you might ask? Well, honestly, we can't provide an answer with any certainty, of course. The most educated guess so far from T.J. Cox and Avi Loeb of the Harvard-Smithsonian Center for Astrophysics, they published a paper in May 2008 issue of Monthly Notices of the Royal Astronomical Society entitled "The Collision Between the Milky Way and Andromeda." Admittedly, be wary of the term collision. Even a galaxy containing billions of stars is mostly empty space. To quote a December 2023 Astronomical.com article, if the Sun were a ping-pong ball, then Proxima Centauri, the closest star to the Sun, would be a pea, about 680 miles or 1,100 kilometres away. In that paper, they predict a 50% chance that our solar system will be pushed away from the galactic core by 3 times its current distance of 26,660 light years. That displacement would propel the solar system toward the outer edge of the newly formed supergalaxy. Cox and Loeb also calculated that there is a 12% chance that the turbulent collisions will eject the solar system into the vast gulf of intergalactic space. As for the solar system itself, stellar models assure us that the Sun will still be a main sequence star during these mergers, although it will be reaching the end of its core hydrogen burning phase. There will be no life on Earth at this time. Increasing solar luminosity will have eradicated all life at about 2.8 billion years before the first Milky Way Andromeda close encounter. However, if this were not true, and provided the Earth wasn't dislodged from the solar system itself, even the solar system's ejection into the intergalactic space wouldn't imperil life on this planet. Remember, we rely on only one star, the Sun. Being propelled away from other stars, although not an ideal situation from an astronomer's point of view, would cause us little harm. Based on the distance to Proxima Centauri, which is 4.2 light years, the Sun and its attendant bodies are isolated with a sphere of some 310 cubic light years. So we're quite displaced from the other stars already, and we are still alive and well. All these interesting things that are going to happen well off into the future. It's pretty amazing. Nothing would be more interesting to see Andromeda getting bigger and bigger in our skies. That'd be something to see if we could just go off into the future and see that. All right, I think on that note, we shall now just go quickly to space weather. The solar wind is currently at 325.8 kilometers a second at a density of 3.36 protons per cubic centimeter. The disk of the Sun is currently looking like this. If we could look at the Sun right now. So there's a few sunspots there. The current sunspot number is 123. The radio sun, the flux, 10-point measured at a frequency of 10.7 centimetres, is currently 178 solar flux units. 178 solar flux units. The aurora glow over Antarctica as we speak looks a bit like this. So there's not a whole lot at the moment to be writing home about, as I say. It's a bit of a low res image, that. I don't know why it's come out so low res. Anyway, there's not much happening there. And the KP index, where is that KP index? There it is. The planetary K index is currently equal to 1, which is considered quiet. Over the next 24-hour, max will be 3, KP 3, which is also considered quiet. And let me just go back to camera. There is something else here. Extreme compression of Earth's magnetosphere. During last May's solar superstorm, Earth's magnetic field was extremely compressed, according to a new study in the research journal Space Weather. The day-side magnetopause was so squashed that the geosynchronous satellites were outside the magnetosphere's protective cocoon for 6 hours. Remarkably, no satellites were lost, although data transmission from some weather satellites was degraded. And the next part is solar max is a second peak coming. And there's a graph here. Where's my graph? There's my graph. Bring that up. Okay, just briefly. Last October, NOAA and NASA announced that solar max has arrived. Only half the sun got the memo. The majority of solar activity has been happening in just one of the sun's hemispheres, the south. The solar superstorm of May 10, for instance, was in last year, was caused by a monster southern sunspot. It makes you wonder, is the other half of the solar max still coming? This plot on the screen at the moment, this plot of the hemispheric sunspot numbers from the SO provides some context. Here we see all 7 solar cycles of the space age, punctuated by current solar cycle 25 on the far right. The most recent cycles are doubled peaked, with northern sunspots in green and the southern sunspots in red, reaching their own solar max 2 years apart. This isn't big news. Researchers have long known that the two hemispheres of the sun are slightly out of sync, the north versus south delay, which is called, and this is a difficult word, it's called the Genevieve gap.